Hello and welcome everyone to this webinar series on DAB Digital Radio, which is co-organised and co-hosted by WorldDAB, the Arab States Broadcasting Union and the Asia Pacific Broadcasting Union. We're delighted to see such a diverse audience joining us today, made up of broadcast radio professionals, media regulators and technical experts from around the globe who join us to explore the progress and the new developments in DAB+ that we've seen that have taken place over the past year. We've witnessed significant progress with new markets launching or expanding their existing DAB broadcasts, particularly in the Middle East, Africa and the Asia Pacific regions. And in the more established markets in Europe, we've also seen consolidated growth. You'll hear more later. So the drivers behind this widespread adoption are the economic advantages and specific benefits of DAB+, also more later. I'd like to say thank you to our speakers who join us and who come from across the WorldDAB membership and who bring with them a wealth of experience and knowledge on DAB+ digital radio. Their insights and expertise will provide you with valuable perspectives as you plan the launch of DAB in your region. We hope you find this webinar series informative, and I encourage you to engage actively with our speakers. Please do ask your questions using the Q&A box below, share your thoughts and make the most of this opportunity to interact with leading experts in the field. And now I'd like to hand you over to Dr. Veysel Binbey, who is the Director of Technology and Innovation at the Asia Pacific Broadcasting Union. Over to you, Veysel.
Yes, good morning and good afternoon for everyone all over the world. For the dear esteemed attendees, participants, broadcasters, and regulators, and whoever attends, let me enlighten and highlight this collaboration, particularly with ASBU, our sister union, and WorldDAB. It's our pleasure, really, because you see that literally now in this webinar, we are with this collaboration with ASBU and WorldDAB, actually we are reaching out more than half of the world. So this is important, and I see that, I feel that, and it's obvious. When we come together and collaborate, we are getting stronger, and our voices to be heard and reach out more valuable, more people, and this reaching is important, and this collaboration is important, especially nowadays, as you know. Broadcast landscape is drastically changing, and it's highly dynamic, quite slippery, and everyone is trying to find the path. It's kind of blurred. For broadcasters, it's not obvious because it's changing. But as far as I can say from my perspective as ABU Director of Technology, radio is staying hold strong, and it will stay strong. Radio's position has been on debate, actually, subject of the debate all over the years. We see that, but this is the important part. We see that it stands still, and it will stay stand still for as a main, one of the main way of the broadcasting. And in this manner, digital way of radio broadcasting, as DAB is doing now, is quite important. That's why we have these attendees, and we have this high level of attendees for among our broadcasters, working professionals. And I'm joining Bernie to invite everyone to make maximum benefit, get whatever you need in this webinar, and I can encourage everyone to ask questions and interact with our esteemed speakers, because we have really highly respected and high expertise all over the world, as you can see, and as you will be able to listen. So I don't want to take your time more, and I'd like to hand over again for the start to webinar, and leave you with our speakers. Thank you.
Thank you. Thank you very much, Vaisal, and totally agree with everything that you just said. Very wise words. And now let's hear some welcome words from Dr. Adnan Salhab, who is head of the Technical Training Department at the Arab States Broadcasting Union. Dr. Adnan.
Good morning, everybody. Dear all participants, on behalf of the Arab States Broadcasting Union, ASBU, and of its Media Training Academy, I express to you our sincere greetings and most welcome. We are delighted and deeply honored to cooperate once more in this event, along with our partners, the ABU and the WorldDAB, in conducting this online workshop on DAB+, which is attended by a large number of interested participants, in addition to the participation of high-level speakers who are internationally known as experts in this field. First, allow me, please, also to pay tribute to my colleagues at APU and WorldDAB and the noteworthy efforts that this team has made in the preparation and organization of the workshop in close coordination with ASBO Academy team. I would also like to warmly greet the expert panel members of this online workshop who will surely ensure its success, and my special thanks to Dr. Les for moderating this workshop in addition to delivering his presentation in the different sessions. Finally, I would like to recall that ASBO has adopted the DAB+ system years ago. The details of the implementation process of DAB+ and the development and its development in the various regions of ASBO will be left for the last day of this workshop, where my colleague, Engineer Mohsen Humam, head the transmission department at ASBO, will highlight some related important points to the development of DAB+ in ASBO region. Thanks to the list for the listening.
Thank you very much, Dr. Adnan, and a special thank you to you for all your help for championing DAB+ within ASBU and across the Arab states. So we really appreciate all of your efforts. And now, finally, let me introduce you to our moderator for this webinar series, who is Dr. Les Sabel. And Les is the chair of the WorldDAB Asia-Pacific Technical Committee and a DAB+ expert broadcast engineer. Over to you, Les, to moderate the session.
Thank you very much, Bernie. A pleasure to be here again. It's always an exciting time with such an international audience. And we are certainly going to showcase a lot of international activity during this workshop. So I'll just share my screen. Share. Okay, that should be sharing. So this is the 2024 version of the ASBU-ABU WorldDAB workshop. I was going through my notes before this workshop, and the first one was actually in 2015. So this is actually the 10th year of doing these workshops. So we've been doing this for quite a while in different formats, and of course we missed one during COVID, but it's a long-term business, and we stick around. So things have changed a lot, and we're here to learn about that today and tomorrow and on Thursday. So thank you very much for the opening remarks from Ms. Bernie O'Neill, Dr. Vaisal Binbay, and Dr. Adnan Salhab. And today we are going to focus on technical updates and business updates. So we have on economics, environment, and emergency, the business case for DAB, we have our president, WorldDAB President, Ms. Jacqueline Bierhorst. That'll be followed by a technical update from Mr. Lindsay Cornell, who's the chair of the WorldDAB Technical Committee, doing some very fine work there. We'll then have a use case on DAB+ for a national emergency warning system by Mr. Carsten Zorger, Director of the Digitalradio Büro Deutschland. That will be a very interesting presentation. And finally, I will give you a bit of an update on how 5G mobile networks can be used in the radio ecosystem. And we'll have a bit of QA hopefully as well, given time. So having said that, I will now hand over to Jackie for her presentation, and please share your screen and carry on, please. Jackie, thank you.
Thank you. Thank you. So thank you, Dr. Les. Yes. And thank you all for inviting me today. We are delighted to be part of this important annual event once again, though for me it's the first time. A core part of WorldDAB's work is that we bring everybody together. And we stand united around the world, working with our friends at the Arab States Broadcasting Union and the Asia Pacific Broadcasting Union, as well as together with other organizations such as the EBU and the Southern African Digital Broadcasting Association. And here you can see my colleague Bernie O'Neill at our stand at the ABU Digital Broadcasting Symposium in Kuala Lumpur this year in March. And here she's talking to Tioni Ching, Malaysia's Deputy Minister of Communications. And I just want to place on record how much we value these links and thank you for your continued partnerships. They are essential if we are to achieve our goal of securing radio's digital future. My name is Jacqueline Bierhorst, and here I am at the Žižkov Tower, Broadcast Tower, a DAB broadcast place in Prague. As you can see, I'm always very happy with towers in my neighborhood. And I've been working in media since 1987. And in the past 35 years, I worked for the broadcasters, both public as private, and helped the change in distribution methodology in both TV and radio from analog to digital, with the focus on the Netherlands, but also in other countries. And in my role as president of WorldDAB, it is a privilege to be able to work with even more broadcasters and regulators around the globe on helping radio getting digitized and making sure broadcast radio in the digital era helps keeping the culture, music, and trustful information freely available to all citizens and keeping people safe and accompany them as a friendly voice. It's so important to understand the reasons for deploying DAB+ and what the benefits are for broadcasters and listeners. The major benefits for listeners is a significant increase in choice. And we are seeing on average up to 5 times as many services on DAB+ as on analog. It also offers, DAB+ offers clearer sound for listeners, particularly where FM is overcrowded. In many cities around the world, FM is full, and which stifles innovation and creativity in launching new services. So for broadcasters, DAB+ offers the opportunity to innovate. Here you can see a classic example from the UK. On analog, there was just one radio station called Absolute. And on DAB+, they now have 10 radio stations. So the portfolio on DAB+ allows more targeted audiences than was possible on a single station. For example, decade stations, country music, and classic rock. With the result, they were able to triple their audience over the past 10 years. In January 23, they even switched off their AM analog transmitters. And in Q1 24, the audience research showed that they had a record audience of 5.5 million listeners aged up 15 plus, from 5.3 million the year before. So incredible growth. This is also an example, because DAB+ also offers the opportunity to extend the reach. LBC was a London-based news talk radio station for 40 years. But with DAB+, they were all of a sudden able to go national. So audience today is 3.3 million, so it tripled the audience. So a world of opportunities is offered by DAB+. And this one's really cool. Global media and entertainment is in the UK and in Europe the largest radio and outdoor company. Last month, their capital brand launched a pop-up station called dedicated to Taylor Swift, called Capital Taylor's Version, to celebrate the Eras Tour coming to the UK. It's the first time in the UK that a national DAB+ radio station has been dedicated to a single artist. And this you can't do on FM because it's overcrowded. And people value that choice on DAB+. 22 million people in the UK listen to services that were not available to them on FM. So that's approximately 50% of the adult population. But it's not just about giving listeners more of what they want, because the growth in listeners is driving up revenues for commercial radio stations. Here we see the UK commercial radio revenues over the last 10 years. It increased by 33% in a context where online advertising has exploded. For radio to perform this strongly is testament to strength of the brands and the reaction to the listeners. And then very important, we just heard very briefly on how Bernie mentioned it already, the 3 E's, the macroeconomic reasons for DAB+. So you see economics, the costs of distribution are lower than FM. Environment, energy requirement is lower than on any other platform. And emergencies, there's resilience, especially out of home. And these aspects are becoming more and more important to all stakeholders. Let's have a look at the economics. The annual cost to broadcasters for transmitting a single service on DAB+ is around 80% lower than on FM. Reason is multiple services on a single multiplex, so the costs are shared across the services. Those economics are being improved even further through innovative new approaches referred to in the UK as small-scale DAB+. This picture shows, for example, the transmission equipment for a small-scale multiplex in a small city of around 300,000 people, and it's on the roof of a local council office. So broadcasts may be based on open source software and use non-traditional transmission sites, and this approach has been adopted in several European markets. And it allows smaller, local, regional community stations to find an economically viable way of getting onto DAB, alongside larger services already on DAB. And it also allows new countries to find a low-cost way of entering the market and starting DAB+. And let's look at the second E, environment. DAB+ is the green solution because it consumes significantly less energy than FM. BBC research published in 2020 looked at energy consumption of both distribution and receivers, and it found that DAB was 33% more efficient than FM and more efficient than IP delivery. And I just wanted to show you these numbers from a German study. These DAB+ stations cover almost the same area or more as FM, but look at the energy consumption compared to FM. At a time where energy prices are higher than ever, and we all want to be green, DAB+ is an obvious choice. And a key benefit of DAB+ is resilience. DAB+ offers text and images as well as audio. And particularly in times of emergency, mobile services are less robust, networks overloaded or out of action. DAB+ is robust and of benefit as part of a national emergency infrastructure. Germany incorporates DAB+ as part of its national emergency warning infrastructure. And WorldDAB Technical Committee and Steering Board signed off the technical specifications last month. And I'm looking forward to hearing more about this very shortly from my colleagues Lindsay, Cornell and Carsten Zorger, who have been working very hard on this project, which we hope will assist in saving lives around the world. So those are the core benefits of DAB+. And around the world, countries are recognizing this and are moving forward. In the 12 months since this group last met, the rapid global growth of DAB+ has continued. In Europe, the rollout is largely complete, as you can see. In France, new transmitters have grown to coverage to over 60% of the population. In Germany, the second national multiplex added 8 new transmitter sites in 6 federal states last month, and very soon, further sites will be added in Bavaria, bringing coverage to over 70% of the population. And also last month, Austria launched a new national multiplex carrying 14 stations, as well as 5 regional masses. And in Spain in February, I was delighted to attend the launch of DAB+ by the public broadcaster RTVE. It launched in Madrid, Barcelona, Valencia, Seville, Murcia, and Bilbao, and every month they add a new city, including especially holiday places like the Costa del Sol and Tenerife, because there are a lot of rental cars. And due to the EECC, they think that there are many rental cars with DAB+ on board, so it pays off to have DAB+ stations in those areas. And they estimate that approximately 50% of the population will be covered by the end of this year. And we're so pleased to have RTVE as part of the DAB+ family. So also in the last few weeks, there have been significant steps towards switchover in Europe. In Switzerland, the public server broadcaster SRR announced it will switch off its FM transmitters in less than 6 months' time from now, so before the end of the year. The proportion of people who listen to radio exclusively via FM has now stagnated at less than 10% in Switzerland. So to save money on transmission, it will stop FM broadcasts on the 31st December. And in the German states of Schleswig-Holstein, private and public radio stations have reached an agreement with the state government and the state media authority to gradually switch to DAB+ digital radio broadcasting by 2031. In 2025, 4 stations will migrate completely, and further station will then follow. I won't explain it completely, but there's a complete schedule to do this, and it will all be switched off by June 2021. And it's not just a European story. I was pleased to be part of an online seminar with the team at RRI Indonesia recently, working with them as they also developed DAB+ following regulation published last year. And last month, the regulator in Thailand, NBTC, published a report on the successful DAB+ trial and is now consulting on a frequency plan and specifications for transmitters and receivers. And in Australia, that market is very well established. ABC and SBS launched DAB+ coverage on the Gold Coast in May, and audiences are growing, including, amongst others, younger listeners. The first ratings of 24 show 4.7 million listeners listening to commercial radio on DAB+ devices, and listeners aged between 10 and 24 years old were up by 5%. And that is a bucking trend if you compare that to analog-led markets. But also across Africa in the last 12 months, we've seen the launch of the trial phase of DAB+ in Ghana, covering Accra and Kumasi, and a pilot project in Uganda, covering Greater Kampala, and interest from many others. Just last month, Senegal launched its DAB+ pilot with 32 stations broadcasting across 2 multiplexes from Dakar. And in the Arab states, we also welcomed the Saudi Broadcasting Authority launching DAB+ in Riyadh, Daman, and Jeddah, with 6 stations on air. And it's expected that DAB+ will be available in all regions of the kingdom in the 4th quarter of this year. And Bahrain officially also launched DAB+ services last August, with 10 stations on air. Let's talk briefly about launching DAB+. Throughout the world, we do that by using the 5 Cs. Let me give a short explanation of the 5 Cs. You see policy and regulation at the top. Government and regulators will determine the direction and strategy for the 5 Cs, preferably together with broadcasters, both public and private. And in the bottom, you see the vital C that's across all of the other C's, and that's collaboration. And all the industry stakeholders must come together to drive the 5 points. And here are the C's. So the first is coverage. You need good coverage of cities, towns, and road networks. You need compelling content, propositions stronger than FM. You need consumer devices and working with leading manufacturers and retailers, making sure that they are available in your country. And cars, for example, in the EECC, in the European Union, penetration will grow steadily, but ensure coverage is good too. So you need, so you can receive it well in cars, and communications. So promotion via FM and other media about DAB+ is essential, so people learn what it is. And you already heard me briefly, policy and regulations play a key role in a successful launch of DAB+. In return for investing in DAB+ infrastructure, a government will help broadcasters, for example, by renewing their FM licenses, or relax regulation in advertising formats or production or cross-ownership rules, relax those. Or perhaps even public funding can be found to support the rollout of the infrastructure, like done in Switzerland, or finance the marketing of DAB+, like done in Belgium. On the WorldDAB website, you can find links to the DAB+ logo and the brand toolkit, because marketing is important, and they're all freely available to download. And also on the WorldDAB website, you can find links to the DAB+ consumer websites of countries that have implemented DAB+. And we share marketing cases as well. It's really nice. To conclude, WorldDAB and my colleagues in the project office stand ready to support you in all aspects of your work on developing DAB+, whether you are at the start of your journey or enhancing established markets. I'm also delighted to say I will be a keynote speaker at Radio Days Asia in September in Kuala Lumpur, and I hope I will get to meet some of you in person there. We'd also love to see you at IBC in Amsterdam this September, or at our own WorldDAB Summit in Zagreb in November. All the details you can find on our website. I hope you find the workshops across the next few days interesting and exciting, and I thank you very much for your time.
Thank you very much, Jackie. That's great. I'm really pleased to see all of that progress that's going on. And I think that's one of the main things about WorldDAB as an organization, and with support from the ABU and the ASBU, we're always moving forward, whether it's new countries and new developments, or it's new technical capabilities. So now we're going to hear from Mr. Lindsay Cornell, Principal Systems Architect at BBC Digital, and of course, the Chair of the WorldDAB Technical Committee, about what they've been doing in the Technical Committee over the last year, and some of the exciting new developments. So over to you, please, Lindsay.
Thank you very much, Les, and good day, I will say. Good day to everybody, given the wide range of locations people are tuning in from. I'm Lindsay Cornell, and as Les introduced me, I chair the Technical Committee in WorldDAB, and I'm going to give you the technical update and let you know what has been happening since last year. So I'm going to cover 3 topics. I'm going to talk about what we do in the TC, in the Technical Committee really, which is looking after the standards, but also the new emergency warning system, which we have developed. And lastly, I'll just touch a little bit on receiver testing. So in terms of standards maintenance, so the Technical Committee's role, central role in the WorldDAB organization, is to maintain the standards, make sure that the standards are relevant and that they work well for everybody. And the good news is that for some parts of the standard, the core technology of the standard is completely stable. The first European services went on air in 1995, and the core technology for modulation is unchanged since then. And the first DAB Plus services went on air almost 15 years ago, improving the efficiency of DAB as a transmission platform by using more advanced audio coding. And the reason I say this is a good thing is because it means that manufacturers, suppliers of equipment, both in terms of consumer equipment, transmission equipment, building the systems, putting transmission equipment on air, those suppliers are very, very experienced now. And the products are very reliable. They've been honed, they've been improved, and they're also very energy efficient. So the efficiency of transmitters, when we first started in the BBC, we had transmitters with quite poor electrical efficiency because of the nature of the signal. Over time, those transmitters are now about 4 times as efficient as they were when DAB started. So a lot of work has been done already to make sure that the system is in really good shape. And in terms of receivers, there are more than 100 million DAB receivers in daily use through the world. So whatever product it is that you need, there will be a supplier that's ready to help you with that. So although we don't need to work on the core part of DAB, we do work on making sure that DAB stays relevant given all the other changes that happen within the environment. And one area that we have spent several iterations working on is the service and program information. And this is the specifications which describe the content. So from the early days where DAB was revolutionary in providing a station name instead of just a frequency, we've moved on a long way since then. And now there's logos, there's program information, program guides. All of these things are possible for people to use. And the specification for this comes in 2 parts. There's a description of the metadata, and metadata is the language of describing what is the content. Describes the audio, the content of your services, who's on air, and so on. And this metadata description is in high level, it's in XML, and it's exactly the same format for both broadcast and IP delivery. So hybrid radio fits within the gamut of the SPI. And the SPI also is designed to cover a wide range of use cases, from business to business, sharing information between broadcasters, and perhaps with aggregators for IP delivery, and in terms of delivering the data directly to consumers, particularly over broadcast. And in order to enable this efficient delivery over broadcast, we have a second specification for transport and binary encoding. And that is actually shared between DAB and DRM. So the XML specification we have upgraded in the last year, and the reason for this upgrade was to handle metadata in more languages, to make it much clearer when multiple languages are being used to describe the same content. And this is partly because of the spread of DAB, and we're seeing DAB in countries where more than one language is commonly in use. We also have voice assistants, so we're starting to see in cars and with smart speakers and things like this. We're seeing consumer devices that will respond to your voice to provide you with the choices that you want to make rather than using buttons. But sometimes these voice assistants get confused as to what it is people ask for. So the SPI now has phonemes and aliases to allow the content description to be honed to be what people actually use. And we also provide more guidance about how to use metadata in different languages, and particularly, as I say, where you may be using more than one language to describe the same content. And in parallel with that activity, and because of the increase in the interest in using metadata, the transportation binary encoding specification has also had a workover. We've made it much clearer by restructuring it, and we've provided additional examples and updated those examples to help people understand how the system works. Now, the completely new thing that we've been working on over the last year, particularly, is the emergency warning system. And DAB has had the capability for alerting in emergencies, but that alerting was quite general, quite severe. Basically, it was an all or nothing approach. What we've worked on over the last period is to devise a new emergency warning system, which is much more targeted, much more nuanced. And within that scope, we have two new specifications. So that defines both the system and also a specification to support receiver testing and a compliance scheme. And I've talked before, and I'll talk a little bit later about receiver testing. I've talked about that before because it's quite important that when you have this kind of functionality, that the receiver should really respond exactly as we expect. Now, in terms of the key features of this new emergency warning system, it's a radio system, so the alert messages are spoken messages, so just like a normal radio program. And these audio messages carry the really essential information, the where, the when, what people should do, how they should react. And the signaling allows you to listen to any radio station you like, more or less, and there's cross-ensemble signaling, so it will switch you across from one service to another when an alert comes along. And we have location targeting to make sure that just those people who are going to be in the affected area are alerted, and other people carry on with their day and are not disturbed. We have a sleep and wake up functionality. So there's a very low power sleep mode. Whilst in this mode, the receiver is still monitoring a DAB ensemble, looking for any alerts that might be coming along. And the receivers can then evaluate that signaling, and they either wake up and play out the audio, or they return back to sleep, and they will retune to a different ensemble if that's necessary. And then finally, the receiver testing. So we have a formal specification to make sure that receivers will react correctly to the alert signaling. And this technical standard builds on the standards that we already had put in place for receiver testing. For a compliance scheme, you're going to hear more about the compliance scheme and the use of a recognizable mark. So it's very easy for consumers to identify those products that they're looking for. Now, the system incorporates three key innovations, the first of which is a novel location coding system. As I say, this means that we can target the alert, that those receivers that respond will just be in the alert area. And the reason we need that is because the area of concern and the coverage area of a DAB ensemble are rarely going to align completely. So to be able to target specific areas is very important. We also have a system which is globally applicable. What we didn't want to happen was that every time a new country decided that they were interested, that they wanted to roll this out, that they would have to wait, and we would have to do new work to work out how to incorporate the location coding that operated in that particular country or region operated. So we wanted a coding system that worked everywhere. But we also wanted it to be lightweight and very efficient, which it is. We've also developed new signaling, which is specifically tailored for alerting. So we can identify those ensembles that participate. We can identify incidents, the alert stage, how important they are, and as I say, where it is. And we also have a system for synchronizing receivers, and this is to make sure that there is absolute minimal loss of audio at the start of an alert, so that whoever is listening will hear all the information they need to hear. And also, we need to minimize the power consumption, maximize the battery life. I'll talk a little bit more about that too. But first of all, let me talk about this universal location coding system and how it works. Basically, as I said already, we needed a global solution. We wanted it to be algorithmic so that we would get the same answer always. It should be very highly efficient in terms of the amount of space it uses, and it should pose very, very low requirements on devices. We wanted low-cost receivers to still be low-cost receivers and not have to add a whole load of extra functionality to make this work. So the way the system works is we divide the globe using a hierarchy of spherical rectangles. And the first division of the globe is into what we call zones, and these zones are 36 degrees by 36. And you can see this, the way this maps out onto the Earth. Now, this is a more conventional projection of the Earth, the sort of the normal map of the world, where we sort of flatten the sphere out. And you can see here the way that the various zones are arranged around the world. There are 40 zones covering the populated areas of the world, and then we have 2 zones covering the poles. Now, the way that the location coding works is, first of all, you can see that wherever you happen to be, you will be in one of these zones, or you might be in an area which actually borders more than one zone. That's all possible. But each zone we then divide into 16 smaller squares. And these are polar squares, so they're not, they don't have linear dimensions the same, but we can think of it much more easily in terms of this sort of arrangement. And we divide into 16 squares. It's a binary division. It's very good, fits very well with the use of digital technology. And each of these divisions is then nested. So we divide the zone into 16. We can then divide each of these squares into 16, and each of those squares into 16, and so on, progressing to smaller and smaller coverage areas, such that in the end, we define an area which can cover just about 1 square kilometer. So this is the kind of shows a bit of a progression, going from the zone into a square, selecting one of those squares, selecting another square, and so on. And gradually we build up a longer code, and the longer code covers a smaller area. But you can see that the smaller code fits within the smaller area fits within a larger area. And this is the idea of the hierarchy. And it makes for a very efficient way of finding out whether you are within the alert zone or not. So we base our system on the WGS84 coordinates. That's the system used by GPS, satellite navigation systems. And the full code has 6 digits and has a resolution of around 1 kilometer. And as I say, shorter codes mean larger squares. And we use these location codes to define the alert area by adding together a number of codes. You can cover any kind of arbitrary shaped region, and also to define the location of the receiver so that the device knows where it is. Now, in order to be able to use this localization, the device does need to know where it sits. And for a low-cost receiver, like a kitchen radio, something that you would use in your house, this means that the user enters a code, and the code itself is generated by an app or by a website, might even be provided by the retailer that provides the device. Higher specification devices, more capabilities, might be able to directly input the location from the app or the website using Bluetooth or Wi-Fi. And for a mobile device like a car, where the location's always changing, GNSS, GPS, probably the best source of data to calculate the location codes coming from the satellite navigation system. We don't actually insist on any particular solution. simply that the vehicle should know where it is to within 100 meters. I'll just give you an illustration of this. I'm not going to go through this calculation, but it's really just to demonstrate that it's algorithmic. And the example I'm going to use is the BBC's broadcasting house in London. And so we can find the coordinates for that location, and we then follow the formula in the specification to translate those coordinates into how far south we are. So our system works from the North Pole. We work out how far south we are, and we work out how far east we are from Greenwich. We go all the way around the world, so we have no negative numbers in our calculations. And then we calculate the zone number and we calculate the digits. And in the end of this process, we end up with a location code for BBC Broadcasting House in London as Z10B736BB. And we can plot that out on a map. So this is plotting this on Google Maps with the extent of that particular location code. And so in this area, as we're 50-something degrees north, the actual sort of linear dimensions of this spherical rectangle are a kilometer north-south and about 600 meters east-west. And within there, you can see in the upper corner, BBC Broadcasting House. Now, we also recognize when we're writing the specification that most people, most consumers are not going to be very familiar with something like Z10B7 blah, blah, blah. It's not very user-friendly. They're not necessarily going to know how to enter such a code onto a very simple device, which just has up and down buttons and a select key. So we provide a way to transform the sort of machine location code into a much more user-friendly presentation code, which just uses the numbers from 1 to 8. And we also add a couple of digits to that for error checking by the receiver, so that if the code is misentered by the user, the device can ask for it to be corrected. In terms of the area of the alert, where is the actual incident occurring? It's represented by sending in the signaling channel a number of location codes, which together build up the area. And the way that the device knows whether it should respond or not is by comparing the location code of the device, either entered by the user or from GPS or whatever, with each of the location codes that comes in the signaling channel. And because of this hierarchy of the coding, it just means that those two numbers have to be compared. And if the number coming in the signaling channel is shorter than the full length, only those digits that arrive need to be compared. And this all works because of the hierarchy. So here's an example of the way the coding works. So this is a severe weather warning for northern Germany. On the left-hand side is the data covering the alert area from the emergency authority. And on the right-hand side is the area, the rather slightly blocky area, which is the way that this is turned into location codes. And you can see that all of the area of the alert area is covered and a little bit more, but not too much more. So in terms of how does this compare to the ensemble coverage area, you can see that this is actually targeting right down onto the area to be alerted. So people in other cities, people in other places are not going to be disturbed by irrelevant information. Now, in all of this, we invented some completely new signaling, and this was for a couple of reasons. One was to increase the functionality of the system, and the other was to avoid any legacy issues of things that have been implemented already in receivers, which might react in a certain way and not the way that we expected. So we have various aspects to the signaling. We can identify which ensembles participate in the EWS. This is important so that a receiver knows which ensemble to monitor. and we can indicate the severity and the status of alerts. It allows us to have different systems in different parts of the world, but all using the same specification. So there's some customization is possible, but it's all standardized. Now, in terms of the device, we have different power modes: sleep, monitor, and wake. And the sleep state is designed to consume almost no power. Almost every function of the device can be switched off. The monitor state lasts for a very short period of time. So, and only the RF tuner and the signaling decoder needs to be powered. And we provide the information in such a way that the decision can be made quickly. This is to maximize the battery life of the device. If you were in an emergency situation, you would want the device to respond, but not to be consuming power. And the wake state is just the normal listening mode. So you can listen to your favorite station in the knowledge that if something happens, your radio will switch over and you will hear the alert message. And we had to think very carefully about the way that this sleep monitor cycle would work in order to minimize the power consumption. And DAB provides a very accurate time signal with millisecond accuracy. So what we've arranged is that all of the devices, all the receivers, will enter the monitoring state at the same time. Every minute, seconds count 0, they start monitoring a DAB signal, the one that's been chosen, and they process all the information. So all the alert information will be provided at that time. They process that and they make their decision on whether they should be playing an alert or whether they should be returning to sleep. What this means is it puts a burden on the broadcaster who is targeting these sleeping receivers to make their alert starting at the beginning of each minute or of any minute that they want to start. And because what that allows is that the devices will play the whole alert. Now, receivers that are already in the wake state are monitoring continuously for alerts. And it could be that there are some alerts that are more targeted, say, towards car drivers, and therefore it's not so important whether receivers wake up or not. And in these particular cases, you can make the announcement, the alert announcement at any time you like. So let me talk about the current status and the timeline. So we've developed 2 specifications. So we have the origination system, which describes the capabilities, the signaling, and the necessary receiver responses. And we have the minimum requirement specification, which describes the testing and the results that are needed. And this specification for the minimum requirements builds on the minimum requirement specifications that we already had for DAB receivers. So you don't repeat the testing, it's additive. The specifications have both been approved by WorldDAB. They've been released to ETSI, and ETSI has just completed the pre-approval processing. And so the formal adoption of these standards will begin next week and be completed by the end of August. So we expect that specifications will be published either the very end of August or the beginning of September. And along with the specification, there's also test files so that every receiver will be tested for compliance against exactly the same set of conditions. And this is exactly the mirror to what we did already with the minimum receiver requirements for DAB receivers. So this specification, which I've presented to you in the past, is used as the basis of all receiver testing for DAB. It's used as the technical basis of the UK tick mark certification scheme, and it provides testing for both functional and performance requirements. And our testing for EWS just builds on this already existing specification. We also have a specification which deals with added value signaling, providing the rules for broadcasters and the reactions needed within receiver implementations. And these are for the added value service information, service following, announcements, service lists, and the non-Latin text. And the framework for using non-Latin text provides both a signaling field for the complexity indicators and links into the regional profiles. And I mention this because, again, I was talking earlier about the SPI, the Service and Program Information, targeting more languages. This is, again, our work to try to make sure that whatever market you are wanting to open up, we have the capabilities in the DAB system that are ready for you, and the rules and so on to allow that to happen. So within text handling, we have different regional profiles, including Arabic, including Thai, and new profiles can be defined between broadcasters and industry representatives. We will coordinate that in WorldDAB to create new profiles for you. So thank you very much for your attention. It's a pleasure to be here and to share with you once again the new things that have been going on in the technical committee. Thank you very much.
Thank you, Lindsay, for that excellent presentation. I think the new emergency warning system is a real credit to the technical committee and all of those that have been working on it. It's fantastic. I particularly like the way we can now, or will be able to, maybe from next year by the look of it, focus emergency warnings down to about 1 square kilometre, or even maybe even a little bit smaller, depending on where you are in the world. Along with a host of additional features like wake up and multi-ensemble. So that's all good stuff. Well thought out and very efficient. And now we're going to hear from Mr. Carsten Zorger, Director of Digital Radio Büro in Deutschland, about how they are going to integrate this new capability into a national emergency warning system. So this is the first example of how this fantastic new functionality will be integrated, and is an absolute showcase, I think, for the world to follow. So I think at this point, I'll hand over to you, Carsten. Please share your screen and do your presentation. Thank you.
Thank you very much and welcome. By the way, we don't only have 29 national DAB+ stations, since radio in Germany is federal. We have 300 different DAB+ stations to choose from in Germany. Let me show you some examples what we are doing here in Germany regarding the warning system. We are living in a time of crisis, and even in Germany we can have crisis. A bit more than 3 years ago, on the July 15th, 2021, we had 135 people dead in the German Ahr Valley. This is not the actual picture. This is just next door, basically, to the Ahr Valley. There was a major flood, and 135 people were killed. And we realized, look at that amount of water. Of course, mobile services, DSL lines, mobile phones, they all went off, because when water hits the DSL box and on the curb of your street, it short circuits, and then you don't have any transmissions. And of course, we rely on radio. So there was a radio broadcast, and unfortunately, the flood came very, very late in the evening, and 135 people were killed. And even today, 3 years later, people are not all of them living in their old houses again. They were not, recuperated. Sometimes they moved away. Sometimes they rebuilt their houses. So there were landslides. There was a large-scale rescue effort and extensive damage. Well, we know all, because we are broadcasters, that broadcast is resilient. And the resilience of broadcast is, of course, much better than of mobile networks. It has a wider coverage, and people trust in radio. So we use that idea of people's trust in radio, of the high resilience of radio, and build a warning system. Lindsay now just explained everything. So like a very short recap, what does the new system do? It has a spoken alert under number 1. It has a number 2, geofencing. So it, you can tell your radio where it is, and then it will only react to the certain location where you are, not waking you up too many times if something works wrong, something goes wrong. There's a wake-up function, especially important in the night. We have a synchronization, that means conserve battery life, and there's a chance to wake up the radio every minute at the second 0, so 60 times an hour. It can switch to different ensembles, and if people have heard the alert many times, they can dismiss it. With that warning and with that emergency warning system, as I'm a marketeer, we thought about, we have to think about the term, we have to think about the wording. And we all know that it's an international collaboration. So we asked WorldDAB and the marketing group, and of course, together with the technical committee, to think about the new term that works to the customer. Because emergency warnings, well, they don't sell at the cash register. And the new term needed to be effective across different languages, cultures, including, of course, France, Germany, UK, and of course, worldwide, all the speaking languages. So coming back to emergency warnings, if you were to buy a new radio and you really love to buy a new radio, we know that the warning and emergency, that does not sell on at the cash register. People just do not want to live in fear. Nobody wants to do that. So we had to think again what we can do. And we said, oh, people love radio. Radio's on our side, like a good neighbor, somebody we trust. So again, we build on the trust of radio, not only because high tower, high power, but because of people listening to it. It's more trusted than social media. And we had to change the perspective because we wanted to make sure that DAB+ is always perceived as modern and up to date. We don't want to convey emergency and warning, but protection, and radio is here to help. Like a good insurance. The Germans love insurance. I don't know whether you love insurance, but the Germans always want to sign a paper and say, okay, I have insurance for this, for my car, for my life, for my family, for some emergencies. They love to sign insurances. So the idea of having an insurance with your new radio, that is all very important to many people. So we changed the perspective and came from warnings to safety. So warning and emergency become an alert and a safety message. And we know that the server is always alert. It's running in the background and it's always listening to the situation. I can do what I want. I can make sure, and I am sure, that my radio reacts at the important time. And it works very well. So we came up with the idea of the automatic safety alert, ASA. Automatic safety alert, not emergency warnings. We call it automatic safety alert. It is automatic, it works in the background. Safety, it is a positive term. It provides protection. It's a safety message. It's an audio message. And it's like a good insurance. My radio offers assistance to me. And the alert is a wonderful word in English. It's neutral, to be alert, to be attentive. Like a beacon, it's always looking, is there anything going on? Yes, there is. No, there isn't. So my radio is alert and attentive. It knows what to do, whatever happens. Automatic safety alert. And we have a logo for that, for the new devices. This is how the logo looks like. It plays with the green color behind my back of the DAB+ logo. It's not the same logo, obviously, but it sort of incorporates the color scheme and the fonts, the typography, and it's called Automatic Safety Alert. I asked 2 companies to exemplify that on their boxes. So for example, for the German company Technisat, there are a few examples how this might look like. On the right-hand side, you have the DAB+ logo. On the left-hand side, you have the ASA logo. Here on the right-hand side, you have the DAB+ logo. On the left-hand side, you have the ASA logo. Here you have the ASA logo, for example, but there's more companies, of course, for example, Kenwood, you know this company as well. Let's have a look how they do it. They do it in color on that part because it's a new feature. They make it very big. All the things that are within that radio, plus the emergency alert. Another example, see down here on the right-hand side, packaging. So this is for the consumer facing, making sure that they pick the right radio whenever it's available. Since this is a new service and this is a mark that's only being applied after testing, I'll talk about that in a second, we of course have a trademark. So this is an international trademark. Currently it's for the European Union, for Switzerland and the UK. And we believe having that for the European Union, for Switzerland and the UK, that should suffice for the rest of the world as well. So ASA is already a registered trademark. Now, you only get that for your device if it's certified and tested. These new radios, and this is, thank you, Lindsay, for explaining that very thoroughly. It's all about saving lives. So we cannot fuss with that. So we make sure that every radio has to prove its reliability in the laboratory. We use, of course, independent laboratories, and we are currently doing like an international market comparison between certain institutes. It's all being finished on August 30th, and after the mark is awarded, the mark is awarded after tests are being done, and then of course you can put the logo on the packaging. And technical detail, your radios from manufacturers, they have to pass the digital radio tick mark test, and the ASA test is an additional test that goes on top of that digital tick mark test. Why do we do it? The digital radio tick mark test is a very thorough, very good test. So it's all about reliability. So the whole system works very well. And ASA is just a new feature set that's on top of it. That's why we decided to put this on top of it. So the whole system, saving lives again, is a very reliable radio on the market. And of course, if there is any manufacturer online, we invite every manufacturer to participate in that testing scheme and make the world a little safer with DAB+ and ASA. This is all about now theory, because we are just in the midst of finalizing the ETSI norm and the testing laboratories. But being in German, of course, the German love to do sometimes. They even are capable of it, make things orderly. We want to get forward. So we talked about the whole thing with Frontier Smart, which is a very big chip manufacturer. Of course, this is not, well, there are many more, of course, but we talk to them first because they have 70% of the market. And this is only an exemplary picture. I just picked this from the internet. There will be an IFA demo of the new feature set in a platform on the at IFA at Frontier Smart at their booth. So IFA is from September 6th to 10th. You can see what the system will be practically and theoretically. It's a test platform, and there's a collaboration between, we have seen it already, Technisat and JVC Kenwood, the two first companies that roll out this new system with their devices right after IFA. But this is, again, this is theory coming into practice, and now we need the test, of course. It is important to have a test of the whole system, and I come to that in a minute. Coming back to Frontier Smart, because we talked about them in a minute. This is important here for all the manufacturers. Frontier Smart told us that in mid-November, they will have the final product for mass market. And we want to see, and we are capable to see, brand new ASA capable radios after having been tested, as explained, in the market worldwide beginning next summer. So mass production is planned for the first quarter of 2025, and we'll see new devices in the summer. Now, coming back to the tests, we have in Germany a so-called warning day. We have this once a year. We do it this time on September 12th. And I just told you on IFA, we have the test platform. So now the networks are about to be ready. They are being held workshops in Germany. We are preparing very thoroughly for the 12th of September. And Deutschlandradio, which is the national broadcaster, and many regional ARD programs will participate in that German Warning Day test. We know that as this ETSI norm is just about to be established and formally agreed to in August, on 12th of September, we cannot have it all in the networks, all the programming, all the system. That would be too fast. So what we will try to do on September 12th at 11 o'clock, we have to generate a signal. We have first test devices from Frontier Smart, from the platform, and some from Technisat, and some from Kenwood. We place 30 different radios all about in different locations in Germany. And what we want to test on that very day is wake up from standby. So we have to wake them up, and possibly geofencing. So these two features that are very important for ESA are possibly being tested on September 12th, being the first, well, not best case because this comes later, but the first proof of the pudding in the German system. And with that, of course, we want to show the rest of the world that this can be done and it's reliable, and we are sort of moving forward with the whole system. So this is the end of my presentation, and if we are running out of time, I try to be rather concise. Thank you very much, and I'll be there for questions.
Thank you very much, Carsten. There's a few questions, but we'll save those for the end. I will quickly run through the next presentation, which is actually my own. So without any more to do, I think that the work you're doing in Germany, it's actually more accelerated than I thought. And the fact you're actually doing testing next month, August next month, in September, is really showing great commitment. Fantastic. For now, we will move on to the next presentation. Okay, good stuff. All right, so I'm going to talk about 5G in mobile networks in radio. There's seems to be an ongoing theme of people saying, "Oh, what about 5G? What about 5G? What about 5G?" So I'm going to attempt to give some answers to some of those questions. So I'll talk a bit about 5G capabilities, 5G mobile networks, and using 5G for contribution, for radio distribution, and then there'll be a couple of conclusions. So let's have a look at mobile networks in general. And here's a table showing the different generations that we've gone through and we will be going through. So, you know, we started out with the first generation back in the 1980s. We had 4G in the 2010s. We're currently now going through a transition into 5G in the 2020s, and we can look forward to 6G in the 2030s. And we can see from this table what's happened in each generation. Well, the theoretical download speeds are going up, or the actual download speeds are going up. The latency is going down, and the cell densities also are going up. So what does that mean? Well, let's see what it means for radio. So higher data rates. Well, a lot of these high data rates and the very, very high ones that have been talked about, you know, in gigabits per second, for example, really require lots of spectrum, lots of bandwidth. And they're really only possible in what's called FR2 spectrum, which is typically above 24 gigahertz. Now, that spectrum has its own issues in that the higher you go in frequency, the less distance the radio signal will travel at the same power of transmission. So what we find is to get those very high bit rates, we need to have very high cell densities. For radio, this means high bit rate and more mobile services in an area, but it requires the telco to actually implement those. And they'll only do that in areas which can make use of them. Lower latency. Well, this is all about how fast devices can communicate. And typically the latency requirement for 5G is 1 millisecond, which is pretty good. It's really meant for applications like IoT and autonomous vehicles. For radio, this means low latency links for live events, which is also important. Massive device connectivity. This means radio, better access for wide area events like motor racing. Network slicing is one of the critical network components within 5G. And what it's all about is actually providing high quality of service for dedicated link capacity. And this means for radio, the ability to provide high quality of service on mobile links, something which has not really been particularly possible in the past. There's always been issues with actually getting the quality of service guaranteed by telcos. It's quite unusual. Enhanced security, it's for more robust services, higher energy efficiency, all better for battery powered equipment, all good things. So overall, 5G will provide a range of benefits for both contribution and distribution. And it's particularly maybe to note, however, you cannot have all the benefits at the same time. And this is the classic pyramid in 5G. You can have very high bit rates, but you can't have ultra low latency at the same time. You can have massive machine type communications and densities, but you can't have ultra high bit rates at the same time. So there's always a trade-off. And for the sort of radio applications, we see there's a bit of a trade-off between the reliability and the bit rates, with less emphasis on the density. All right, let's move on to contribution and production. Now, there's been some really good studies done on this recently, and one in particularly by the EBU. Their trials report TR080 is released earlier this year and summarized in a white paper following. And that has been the report on several experiments that have been done with broadcasters using 5G. Now, most of these use cases require non-public networks. That means it's a private network. It's not using a public telco network that you'd normally get your 5G service from, or your 4G service, or whatever service. So, and there's a number of things were found in these studies. And we've got one here, one by NRK in a trial setup. And one of those was that spectrum access is critical. So it means that non-private networks have to have some spectrum availability to be able to actually be constructed. And they're often done on an ad hoc basis. They're put up for specific events in specific locations. So that means some capacity or spectrum needs to be put aside in the 5G regime to be able to implement these, rather than be gobbled up by all the local mobile network operators in your country. So, there's a fair bit of harmonization and regulatory conditions to do that. And the use of public 5G networks will require network slicing capability to ensure that guaranteed quality of service. So let's go back to these trials in a little bit more detail. They were conducted over a period of a couple of years, 21 to 23, by European broadcasters, including BBC, NRK, RAI in Italy, and SWR in Switzerland, and others. They're mainly AV based, but there were some audio only experiments, particularly the Rai one in Italy, which was really quite interesting on live audio performances. And they also included the use of 5G for telemetry, communications, and monitoring. We do know there's a gradual move away from cable-based outside broadcast systems for some time now. However, we also know that conventional PMSE equipment requires individual links and a correspondingly high coordination effort. So a lot of this is about trying to use 5G to reduce the amount of effort to mount some of these major events, particularly outdoors. So always want to minimize setup time and always want to maximize quality. Overall, we found in those studies, the public network tests show that 5G is not currently suitable to replace video over fiber in high-end production. There's no control on how many devices are connected to the network. There's still no network slicing capability available to carve off network capacity. These things are promised and they should be coming, but they're not yet here. Handover between cells can result in unacceptable levels of interruption. Importantly, there was no ability to control up and down link capacity, In public networks, downlink is usually about 80% of the capacity, and that's due to the amount of video that's being consumed. Whereas the opposite when you are trying to implement, reporting on an outside broadcast where you're producing the content itself. And that goes for radio in terms of video too, because these days radio stations often couple video with audio, and that's consumed in different ways, not only during the event, but after the event. In terms of news gathering, 5G worked pretty well the same as 4G. Might get a little better in the future. And the next main steps include easier access to 5G spectrum for non-private networks and the quality assurance aspects. And there's a lot more information about this from EBU 5G MAG, 3GPP, and other organizations we'll talk about in a minute. So now let's move on to distribution. So there's four different cases here in particular. There's delivery of DAB ETI over IP or EDI from the multiplexer to transmission towers. A typical use case there is a backup link. There's delivery of IP streamed radio to 5G mobile phones. There's a potential use of 5G broadcast to deliver radio to mobile phones, and the use of 5G streamed data for hybrid radio, particularly for cars. So let's look at ETI over to delivery to TX sites. Well, here's a little diagram of what we normally see. We'd normally see some sort of telco fiber-based network to connect from the multiplexer site to the transmission sites. And what we're talking about here is a backup to that. Now, that typically currently would be possibly 4G, or more likely to be some sort of microwave link. So we're trying to substitute a 5G link for that backup link. And what we really want to do is ensure a very cost-effective solution. So that means it would need to be via public mobile network operator. So really, to make that happen, we need that network slicing capability to come available and be activated by the network operators themselves. So the price for this type of approach, it should be a relatively cheap backup, but it may not be without glitches. When the network, if the main link goes down, there may be some network glitches in establishment of that 5G backup. They may only be for a couple of seconds, which would probably be a pretty good result. I can't see it being glitchless unless you have that link running all the time, which would be more expensive to operate. Okay, delivery of IP stream radio over 5G to mobile phones. Well, with all of the additional capacity, it's pretty clear that there will be some improvement in availability. So the pros are really, can access radio services via personal smartphone, which in most cases you can do it anyway. The cons are that mobile networks are still less reliable than broadcast. It's been demonstrated time and time again. And I think just the examples of the emergency systems that we've been hearing from Lindsay and Carsten are good examples of that. When you do have major disasters, there aren't any mobile networks. They've gone down. There's no power. They could be flooded, non-operational, no interconnect communication. And of course, quality can also be reduced through delays, jitter, and network outages. Now, there's a couple of studies there available if you want to look this up in a bit more detail. There's a report by Plum Consulting looking at wireless delivery of audio services. And there's also a BBC project called Timber looking at a similar situation, exploring quality of experience for radio over mobile networks. So I'd encourage you to look at those reports and those activities. So let's move on to 5G broadcast, because that's an area which people seem to think might be a bit of a winner. The trouble is it's got a number of issues. We've seen 5G broadcast, known as originally known as MBMS, and then FEMBMS, then Future MBMS, or 5G Multicast Broadcast Service. It's now MBS, and it's moved on quite a bit from release 14 in 2017 to what's coming out now as release 18 this year, later this year under 5G Advanced. And it's being pushed by major companies like Qualcomm, Rohde & Schwarz, and even the EBU to some degree. But still, to date, there are no commercially available 5G MBS capable smartphones. Not to my knowledge anyway. If you know of one, please let me know. That would be great. Now, it's got many useful features to make mobile communications more capable and efficient, but will it really replace broadcast? Well, there's a number of issues here. The main one here I'll highlight in this presentation is the operating frequency. The operating frequency needs to be in the UHF band. That's where digital TV is. And in fact, would take capacity from broadcast television, terrestrial broadcast television, in these typical bands. And there's some agreements on spectrum sharing and band sharing for mobile networks in these bands. Often, however, though not on a primary basis. The primary basis is actually for digital terrestrial television. Now, the fact that this is operating in UHF 470 to 698 megahertz relative to DAB in the VHF band 3 means propagation losses are somewhere between 6.6 and 11.7 dB higher to use that band for the same service. So that's immediately a big red flag. We also know that, given 5G receiver bandwidth being larger than a DAB receiver, there's going to be more noise and less sensitivity. So that's another problem in places where signals are weak. And also we know that 5G broadcast doesn't currently include any time or frequency interleaving. And that's a penalty in the harsh environments that radio works in rally environments, non-line of sight, fading environments of at least 7 dB carrier to noise ratio. So what this means overall is that 5G broadcast at the lowest possible frequency in UHF, which is unlikely to be used anyway, would be at least 13 times or maybe even up to 20 times in higher frequencies than the equivalent DAB coverage. And that means you need to operate effectively at 20 times more power. Now, obviously, in a mobile network, you'll have to have many, many cells, and you'll be a very big distributed single frequency network, but it just goes to show that the power consumption in this situation is going to be far, far greater, making it quite a lot less economic, let's say. On top of that, we've got the availability of 5G broadcast receivers. Now, we know 5G is being included in all new smartphone designs these days, but support for 5G MBS, and particularly broadcast, is unclear in most phones. I did some research on this, and I found it very difficult to find any that say they've got this capability. And on top of that, you still need the mobile network operator to support broadcast. And we know they've got a track record from our many years of trying to get DAB in mobile phones of not liking broadcast and seeing it as an actual competitor. So it's a bit of hold your breath in that space as well. Now, on top of that, we have the Plum report I mentioned earlier in 2021 that indicated there's little economic benefit for using this for large-scale broadcast services, and further advances in 5G will still require economic justification. That's on page 37. So overall, it seems very unlikely that MNOs will promote radio delivery by the MBS service. That may change, but that's certainly what the facts are saying these days. So is 5G useful in radio? Oh, absolutely. Great for content capture and for live production. Can 5G be used for the distribution of radio streaming services? Absolutely, it's better than, it will be better. It probably is already better than 4G when you can get 5G, if you have a 5G phone, of course. However, studies to date have shown availability and reliability is not as good as DAB+. Can 5G broadcast replace DAB+? Well, I'd say no. It needs more power, it needs more sites, it's much more costly, and it's not guaranteed to be supported in all smartphones or by all mobile network operators. Will it be included in cars of the future? Probably in some form, but probably not for radio delivery. It is useful for many other things, just not really efficient for radio or television delivery. So I hope that helped answer some of your questions on whether 5G is the way to go for broadcast at the moment. I'd say no. So thank you for that. Time is already up, so I'll stop sharing this presentation. And do we have some questions? I think most of them have been, or the main one's been answered. I have one here for Hatim Zuni, who asks the question of the ASA for emergency warning. It's been proposed what are the advantages of that? I think Carsten did sort of mention that, but I'd hand over to Carsten just to give a more definitive answer on why you think that ASA marking is really important for new phones, new receivers with that capability.
Thank you very much, Dr. Les. Well, look at the picture. Once again, high tower, high power broadcast is resilient. This is why we do it. It's additional to all other services, sirens, loudspeaker wagons, whatever. But 5G broadcast or 4G broadcast or LTE or whatever mobile services, there was no local mobile service at that region because everything was flooded. So we decided that broadcast might be here to help, and it's the resilience of broadcast and the trust in radio that people have, and why ASA is so good, and why ASA is the successor to the alarm announcement of 2016, is because it has these 5 new features. Because number one, alert, a spoken announcement alert. This was the one we already got years ago with the so-called alarm announcement years ago. And the other 5 items, geofencing, wake up, synchronization, switching function, dismiss. These 5 new features that are so much better in comparison to other services, especially when the mobile network is not available or as an additional feature to regular mobile networks. This is why we think ASA is superior to other systems.
Thank you very much for that, Carsten. Very good answer. I have another question about the existing receivers and their capabilities to support the emergency warning system. This is from Mosa, from SBU. Lindsay, would you like to address this one, please? And I'll read the question. What about existing receivers, how we can update them to support EWS, the new EWS system? Can you elaborate on that, please?
Yeah, sure. So, I mean, as regards to receivers in vehicles, my understanding is that many of them can be updated. Some of them can even be updated over the air. So the owner doesn't even have to take the vehicle into a garage to have the software upgraded. The system is purely understanding new signaling. So there are no hardware additions required. If the receiver already is integrated with the navigation system in a car, it knows its location, so it's a software upgrade. So many cars can be upgraded. The receivers can be upgraded for this. For domestic receivers, There are a few that could be upgraded. The majority, though, are built to a certain price, and therefore you will need a new receiver to support the ASA function. But you might not need to replace every single receiver. You might choose to replace your radio alarm clock, for example. Something's by your bed. That's where you think the system will be most useful. So gradually we will see this happening. But what we do know from the design is that other than the additional software capability decoding the new signaling, there is no additional hardware cost for domestic products. You don't need anything new. There's no extra navigation or location or anything. So this means that, and you heard from Carsten about the plans that Frontier Silicon have, they can add this functionality to their existing solution, and so newer devices will be able to include this functionality straight away. Thank you.
Thanks, Lindsay. I've got a little bit of a follow-on question. We heard from Carsten that we're expecting to see domestic receivers becoming available on the market in probably the first quarter of next year, summer, Northern Hemisphere summer. Has there been any indications of when car receivers might start to adopt this capability?
I have not received any specific timetables from any car manufacturer so far, but there has been a lot of questions from car manufacturers. So my guess is this is something they're already looking at, but I don't have any timeframes on that specifically.
Okay, thanks, Lindsay. I'm sure we'll see a plethora of adoption next year in the car space. As you say, a lot of this is, well, it's pretty well all signaling, so software-defined radio would support that very well, it's particularly because there's no wake-up function for cars. All right, time is well and truly up. So I've just answered one other question about availability of these presentations. All the presentations from this series over the coming 2 days as well will be made available at the end of the workshop, and you'll be able to download them, all of them, at that point in time. So for now, though, I would hand back to Bernie to wrap up the day, please.
Thank you, Les. Well, listen, we're over time, so I don't propose to go over again what everyone said. Suffice to say that the presentations were all excellent. And of course, the highlight is that significant work that Lindsay has done within the WorldDAB Technical Committee on Emergency Warning and the adoption of it in Germany and the availability of all that work to the global community of broadcasters. This is hugely significant work. And to find out anything more about that, suffice to contact the WorldDAB Project Office, and we are waiting for your questions. So thank you to all our speakers today, to Jackie, to Lindsay, to Carsten and Les. Thank you for your presentation and the excellent moderation. As Les said, the PDFs will be available afterwards from today's session and all the sessions over the coming days. And Les, can you just tell us briefly about what participants will hear when they join us tomorrow and also for Thursday morning session?
Yeah, sure. Thanks, Bernie. So we've seen the business case and technical updates today. You should be able to see my screen here. Day 2, we're going to hear a lot more technical aspects. We will hear about system features from me, head-end systems from LP at Panida. We'll hear about latest updates in transmission systems from Oscar at Gates Air, and new developments in antenna systems from Roberto from Aldina. So a very technical session tomorrow. Then on Thursday, we've got a bit of a variation here, and we're really talking about building out the network here and some international updates. So we're going to hear from Dr. Laurie Hallett about new and innovative ways of delivering DAB, particularly in small-scale settings. We're going to hear about new activities in the automotive industry, particularly outcomes from the recent automotive workshop. We'll get an update from myself on Asia-Pacific activities, an update on Middle East and North Africa from ASBU from Mohsen Gorman, and an update on Africa about field trials in Ghana from Gabriel Kwofi. And we'll wrap up, if we do have time, we'll have a little panel session that will talk and discuss a bit about planning and rollout, and obviously encourage lots of questions in that space. I will say all good questions, or all questions will get answered, but they may have to be done by email, but we will certainly endeavour our very best to answer all questions one way, whether it's live or it's by email. So thank you, Bernie, for your comments there. And given the time, I'd say thank you to all of the participants, and particularly for staying around. This very good attendance today. So thank you very much. And I hope you have enjoyed this and learned something new today. And please join us tomorrow and Thursday and learn some more. So it's bye for now for me, and bye from our panel, our esteemed panel. And we'll say au revoir, because we'll see you tomorrow. Thank you. Bye.
Thanks, Liz.